Hi, welcome back to this channel. In this video, we are going to focus on solid. So basically, we need to know why the shape of the solid is always fixed. And then also based on the kinetic molecular theory, we are going to explain the process that involve the solid such as freezing, melting, sublimation, and also deposition. Then we have to know there are two types of solid, atmospheres and also crystalline solid. So there are few types of crystalline solids such as metallic, ionic, molecular covalent, and also giant covalent. So we need to know a few examples for each type of these. Let's check with the properties of solid. The shape of the solid always is fixed. This is due to the molecular motion of solid. Most of them are vibrate or rotate at the fixed position. This molecular motion causes the shape of the solid always is fixed. Now let's start with tutorial question number 1. Explain the following process in terms of phase change. So here the phase change is referred to solid, liquid, and also gas. And molecular motion, so means that you can relate with the kinetic energy or the movement of the electron or also the arrangement of the particles. First, we are going to explain the freezing. So freezing is a process at where the liquid will change to solid phase. So now freezing is a cooling process, so that's why we will mention the temperature will be decreased and then the kinetic energy also will be decreased. This will cause the particle move slower and also closer and increase the strength of the intermolecular force. And then now the particles will going to arrange themselves more orderly and then will become the solid. So look at this example. You will try to check that you have to mention whether it is heating or cooling process by mentioning whether the temperature is increased or decreased. Then relate with the kinetic energy, mention about the movement, and then also mention about the electron, the particles arrangement. Next process, we are going to discuss about melting. Melting is a process at where solid will convert to liquid. So as we know, this is a heating process. So the solid will going to absorb the heat and then the particle will vibrate faster. Once the solid particles vibrate faster, it will overcome the intermolecular force, or we call it attractive force, and cause the particles move freely, and then there is no longer in the fixed position. Next process that we are going to discuss is sublimation. Sublimation is a process at where solid change to gas phases. So again, this is also a heating process. So we will mention that the solid absorb the heat and then the kinetic energy increase rapidly. This time we didn't use the term vibrate, but we can relate with the kinetic energy. So similar case with the melting. Once the solid particles vibrate briskly or they moving faster, so it will able to overcome the intermolecular forces and then cause the atoms or cause the particles are free moving randomly and cause the arrangement of the particles become disorder. Last process is deposition, which the phase change from vapor to the solid, and this is a cooling process. Then we will mention that the temperature is dropped and then the kinetic energy also dropping will cause the particles closer to each other and then the intermolecular become stronger. And lastly, the particles will arrange themselves orderly because they form solid. So if we look at these four processes, we will notice that we need to mention about the process is heating or cooling by relating with the temperature increase or absorb heat, for example. And then we are going to mention about the kinetic energy. Are the particles move faster or they will move slower? Then we will relate with the movement of the particles, and last we will relate with the molecules arrangement. Okay, generally maybe you can alert there are few terms that we can use to describe the arrangement of the solid. We will say that the particles of solid arrange themselves orderly, while for the gases is disorder. Next, we are focused on the motion of the solid. Always is vibrate or rotate at the fixed position. While for the liquid, we mostly use the term move freely. While for the gas, we are going to use the term move randomly. Question number 2, we are going to differentiate between the atmospheres and also the crystalline solid. So basically, both of these two types solid have the opposite characteristic. So you can either remember crystalline or atmosphere solid. So for the crystalline solid, they have a fixed shape and then they are regular arrangement. They can have a 3D geometry pattern, which they also will form saturated liquid when they are cooled slowly. They have a fixed melting point. So the example of the crystalline solid will be ice, sugar, salt, and copper 2 or sulfate. So while for the atmosphere solid, the example are including glass, plastic, material, charcoal, and also sulfur. Question number 3. Give an example for each of the following type of crystalline solid. Basically, solid can divide to 4 types. First, metallic solid, ionic solid, gigantic covalent solid, and also molecular covalent solid. So in here, maybe we can try to get the idea, the type of particles, type of intermolecular force, and then also the example. But according to the tutorial question, the requirement is the example only. Okay, so metallic atom, they are in atoms, or we can say that they are metallic ion and delocalized electron. And then that's why this is the definition for the metallic bond. Example like sodium, gold. Second one for the ionic compound, ionic solid, we know that the type of particles between them is positive ion, negative ion, cation and anion. And attraction between cation and anion will form an ionic bond. So these are the examples for the ionic solids: sodium chloride, potassium nitrate, copper 2 sulfate. Next one is the gigantic covalent solid, at where the atoms are connected to each into a network based on the covalent bond. So the type of intermolecular force will be covalent bond. Example is diamond, graphite, quartz. The last type of crystalline solid is molecular covalent solid. So either they will in form of atoms or molecule. Because of their covalent compound, so the type of intermolecular force generally will be the van der Waals force. So example is carbon dioxide solid, sugar, phosphorus, sulfur, and also iodine. So after completing the tutorial question, now let's look at one partial question. Give a brief comparison between solid and liquid, and then we are going to fill the blank below. So the shape of the solid is always fixed, while for the liquid is always follow the shape of the container. The surface tension for solid is very small, while for the liquid is very high. The next properties, solid has non-viscosity because solid cannot flow, but liquid can flow, so that's why liquid has high viscosity. Solid cannot be compressed, so it is, you can mention very small compressibility or incompressibility also accepted, while for the liquid, the compressibility is very small also. But if compared to the solid, compressibility for liquid is slightly higher. One more question. Using the copper, diamond, and also sulfur and sodium chloride to represent the various types of crystalline solid. And then we need to identify the type of intermolecular force. So the marks provided here is around 8 marks. So for the copper, as we know, it is an example of copper. So the type of intermolecular force is metallic bond. However, we only have 4 substances over here, but then there is 8 marks provided in this question. So in other words, to say, we have to briefly describe what you understand about the metallic bond based on the substance given. So for example, the question given us copper, so we are going to mention copper 2+ ion are attracted by the delocalized electron. So we need to be more specific based on the question. So second is the diamond. So diamonds is the giant covalent structure. So the intermolecular force among them is covalent bond. So here you are going to mention the diamond, which actually is the carbon atoms. They are tetrahedrally bonded to another 4 in a giant covalent structure. Next one is the sulfur. Sulfur is a covalent compound. So the type of intermolecular force is van der Waals force. So sulfur exists as a simple molecular structure. Last type of the crystalline solid is the ionic solid, and where we know the type of intermolecular force is ionic bond, and then the bond is between the electrostatic force between the sodium ion and also chloride ion. Okay, so that's all for this subtopic of 5.3 solid. So we will continue 5.4 phase diagram in next video. Thank you for watching.